Welcome back to Math Concepts. In this video, we are going to begin our discussion of the concept of probability. So this is a new topic for us in this course. Now, we're familiar with the idea of probability just from everyday life. In mathematics, what we mean when we talk about probability is that we are assigning a number to how likely an event is. Okay, so this number is a measure of the likelihood of the event happening. And this number is always going to be between 0 and 1. Okay, so the lowest probability something can have is 0, and that means that event is impossible. The highest probability that an event can have is 1, and that means that event has to happen. It's a certainty. Most of the time, the number will be somewhere in the middle. The closer to 1, the more likely the event is. The closer to 0, the less likely the event is. Now, when we are dealing with probability in this class, the way we will compute this number and the way we'll figure out the probability of an event is we will look at the number of ways our event could happen, and we'll compare that number to the number of things that could possibly happen. So we'll compare the outcomes we're interested in to all possible outcomes, and we'll make a fraction. So in this fraction, the numerator will always be smaller than the denominator. We're looking at the number of outcomes we care about versus all possible outcomes in our situation. And that's why we'll always get a number between 0 and 1. So when we're dealing with these probabilities, we need to look at sets of possible outcomes. And in particular, we need to count how many elements are in these sets. So we're going to begin with counting principles. And these will often be indirect. We won't simply be listing something out and going 1, 2, 3, 4. No, we won't be doing that. We'll typically be counting with logic. Okay? So let's go to the document camera and look at some examples of using these counting principles. So we're going to be talking about these counting principles. Now, from this video, what I want you to take away is I want you to be able to list the elements in a sample space. Okay? So let's look at a quick example here. When we're dealing with probability, we'll often use tossing a coin as an example, or drawing a card, or rolling a die. So let's start out with an example of tossing a coin. In fact, we're going to toss a coin 3 times. And we're going to list the elements in the sample space. Now, in this particular case, I need a list of all possible outcomes. I'm actually going to use a little diagram to help me organize my thinking here. Okay, so this is called a tree diagram for kind of obvious reasons. So the first toss, I toss the coin the first time and it either comes up heads or tails. And I toss the second time and once again it either comes up heads or it comes up tails. And finally the third toss, okay, so this is a little representation of all the possible outcomes. So this path represents we got heads the first toss, then tails, then heads. This path represents tails, then heads, then heads. Okay, so each of the terminal branches represents one of the possibilities in this experiment. So for example, heads, heads, heads. That's a possible outcome from this experiment right here. And we can see here that there are 8 possibilities. So 8 possible outcomes. And since the question did ask me to list them, I'm going to go ahead and do that with the help of my tree diagram. Okay, heads, 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 that's the first one. So that's 1. Heads, heads, tails. Okay, this one right here, heads, heads, tails. That's my second. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Let's make it really clear that that is a T. Okay, so we got tails, heads, heads, tails, heads, tails, 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 heads. And finally, tails, tails, tails. Let's just do a quick count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got all the possibilities there. So this is the sample space. Now notice each element in the sample space for this experiment has 3 pieces of information. Okay, we have to tell what happened on each of the tosses. So a single run of this experiment is going to involve 3 tosses, and you have to say what happened on each toss. Okay, this right here would be you got heads on the first, tails on the second, heads on the last. Okay, so we can see there 8 possibilities. Now I'm going to show you a little counting shortcut right here. This experiment has 3 stages. Okay, if we're going to do one run through of this experiment, we got to do 3 things. We have the first toss, we have the second toss, and then we have the third toss. Now we have to think about how many ways each of the stages could work out. So the first stage, well, you have 2 possibilities. The coin could come up heads or it could come up tails. And you also have 2 possibilities for the second stage and 2 possibilities for the third stage. 2 times 2 times 2, that gives you 8 possible outcomes. Okay, so the tree diagram is nice and it can be helpful if you need a list, which is what the question asked us for. It said list the elements in the sample space. But oftentimes we'll just need a count of what's possible. And this thinking in stages is very useful for the count. Okay, let's do one more example here. So in this experiment we are going to roll 2 dice. One is 4-sided and one is 6-sided. List the elements in the sample space. Okay, now I just want you to realize that 4-sided die do exist. This is a 6-sided die, of course, right? It's a cube. It can come up anything from 1 through 6. And this is a 4-sided die. It looks like a little triangular pyramid. Okay, so if I were to roll these die, this one's a 1. You have to look at the number that's on top for the 4-sided die, and this came up a 3. Okay, so that's one possibility. So let's apply that counting principle that we just talked about. Okay, we're thinking of stages. I'm going to do the experiment once, so I have to think of, okay, How many possibilities do I have for my four-sided die? How many things could come up there? Well, that part of the experiment could go one of four ways. And for my six-sided die, I'd have six ways. So we would have 24 possible outcomes for this experiment. Okay? And the outcomes would all have two parts. Right? For me to tell you an outcome, I'd have to tell you what happened on the what happened on the four-sided die, what happened on the six. So this one, a 3 and a 5. Okay? I'm going to list these out in a little grid. Okay? So this row, the entries in this row represent the possibilities where the four-sided die comes up a 1. So you could have a 1 and a 1, like that. You could have a 1 and a 2, which would be represented right there. You could have 1 and 3, and so on down the line. Okay? So we can just fill out the rest of the table in this way to get our list. So we have here the 24 possibilities. You can count them up if you need to, but right, it's a table. You got 4 rows, 6 columns. 4 times 6 is 24. Okay, so this represents the three-sided die, or the four-sided die rather, coming up a 3. And the standard die comes up a 4, 3, comma 4. Okay, so all the possibilities are listed right here in this chart. Okay, so this is my list of all the elements in the sample space. So, some notes here. In the context of probability, when you hear sample space, we are talking about the set of all possible outcomes from an experiment. If you hear the word event in the context of probability, that is referring to a subset of the sample space. Okay? So the sample space is the set of all possible outcomes. An event is a subset of the sample space.